So we're going to be doing a question which involves a uniform drawbridge which has a single tie at an angle of 30 degrees holding it up, which means that here we are going to have to balance some torques. So we have a car here at 1 meter away from the edge of the bridge, and we have the weight of the bridge itself at 4 meters away from the edge of the bridge at the hinge. So the torques in the downwards direction, we're going to have the total torque is going to be the torque of the bridge plus the torque of the car. So adding these up, with torque being the force times the radius, we have 4,000 times 4 meters plus 8,000 times 7 meters, because the car is 1 meter away from the very end of the bridge, which means that it's 7 meters away from the hinge. This gives us a total torque of 72,000 Newton meters. Now, to equalize the force in the upwards direction, we're going to have a vertical force acting where the tie and the bridge meet. So that is 2 meters away from our pivot point, so the torque upwards is going to be equal to the force upwards times the radius, and that has to equal 72,000. So we have some vertical force, which we're trying to find, times 2. So the vertical force is going to be 36,000 newtons. Now that we have a vertical force, we're going to have to figure out the tension in the cable, which we're going to have to do using a triangle. So here we have 30 degrees, we want to find our tension, and we know that the vertical force is 36,000. So we're going to have our adjacent side and our hypotenuse, so cos of 30 degrees is going to be equal to 36,000 over the tension. So our tension is going to be equal to 36,000 rearranging over cos 30, which gives us a total tension force of 41,569, or 4.1 times 10 to the 4. The second part of this question, we need to get the size and direction of any force exerted by the hinge on the drawbridge. So if we quickly draw that drawbridge again, we had our tie at 30 degrees and the hinge here. Now, the vertical forces cancelled out from the tie, but if you look at the direction of the tension, our tension is going to be acting up in this direction because we have a vertical force up, but it also means that we're going to have a horizontal force this way, which needs to get cancelled out so that our bridge doesn't move through the wall. So what we need to do is figure out the horizontal force applied by the cable, and then that's got to be opposed by the hinge. So we had our triangle here, which was 4.1 times 10 to the 4 newtons at 30 degrees, and we want to figure out what the horizontal force is. So just using our trigonometry, sine of 30 degrees is going to be equal to a horizontal force over 4.1 times 10 to the 4. So our horizontal force, when you work that out, is going to be equal to 20,785, which we can write in scientific notation as 2.1 times 10 to the 4 newtons to the left. So the hinge, the force of our hinge, has to be equal and opposite to that, so that we have an equilibrium in our forces, so that all our forces cancel out. So the force of the hinge has to be 2.1 times 10 to the 4 newtons right. And that is our answer.